In this video, I'm going to solve a problem using integration by parts. And I'm going to solve it using my favorite method. The popular method is using this formula, integral of u dv equals uv minus integral v du. But my favorite method is when I use this formula, integral of f of x times g prime of x dx equals f of x times g of x minus integral of f prime of x times g of x dx. So how does this blue method work? Well, if I have a product of two functions, and one of the functions is written in prime form, then I can actually write it out. So for example, let me explain what I mean by that. If I have to calculate integral of x squared e to 4x dx, instead of writing which function is my u and which one is my dv, I'm gonna write it in this format, integral of f of x times g prime of x dx. So the antiderivative of x squared is x cubed over 3, which would make my integral even more complicated because it will increase the degree of x squared. But the antiderivative of e to 4x, it's e to 4x over 4, so that wouldn't change my problem much. So I'm going to write it that way, integral of x squared times e to 4x over 4 prime. So I try to mimic the formula that we have here circled in blue. Now what does that mean? Well, once I have a function and a derivative, then I can just write f times g, so I can write x squared times e to 4x over 4 minus integral, and now we differentiate the first function, so it's 2x times e to 4x over 4 dx. So what happened, the new integral that we have has 1 power less, which is a good thing. So we have x squared times e to 4x over 4, and then 2 and 4 cancel, and we get 1 more simplifies, and we get negative 1 over 2 integral of x e to 4x dx. And why is this my favorite method? Because I don't have to do all the u and dv, which is using more space, taking more time. So the same thing I'm going to do here, 1 over 4x to the second times e to 4x minus 1/2. And then again, I'm going to try to write this integral that we have here using those two functions, x, and then the antiderivative of e to 4x over 4. So that's prime dx. And again, we get 1 over 4x to the second times e to 4x minus 1/2, and I want to write this formula out using this integral using the formula. And we know that when we do integration by parts, the integral is going to be broken down into two terms. So I'm going to open a parenthesis and I'm going to write x times e to 4x over 4 minus integral of x prime, which is 1, so e to 4x over 4 dx. And so you can notice how we got a more basic integral now. So this gives us 1 over 4 x to the second e to 4x. I open the parentheses, so minus 1 over 8 x e to 4x, and then minus times negative, we get negative or positive 1 over 8, and then we end up with integral of e to 4x dx, which we can calculate right away. So 1/4 x squared e to 4x minus 1 over 8 x e to 4x plus 1 over 8 e to 4x over 4 plus c. So if I factor out, or I can just write 1 over 4x to the second e to 4x minus 1 over 8 x e to 4x plus 1 over 32 e to 4x plus c. We can factor out if we want e to 4x or so on, but this would be my favorite method of calculating integrals with integration by parts, because it saves a lot of space if you want. Instead of doing the u and dv and so on, we are just looking all the time for an antiderivative. And why we choose e to 4x as our g prime, basically, with some changes, because if we chose x to the second, the antiderivative would be x to the third over 3, which would make it a more complicated integral. I hope this helps.